Hi everyone, it's Rohan this side, and I welcome you all to the new video by Lemniscates Academy, where we are going to go ahead and solve this Cambridge Mathematics P1 paper from the October-November 2024 session. The variant is 2 and the subject code is 9709. In case if you are having any kind of queries while I explain these solutions, please make sure to ask them in the chat below or in the comment section below. And apart from this, if you are having any kind of doubts with respect to how you can join my online coaching, for that you can text me on the WhatsApp via this number. Now, let's get started. So for the first question, the diagram shows the curve with the equation y is equal to a sine bx plus c. So there is some kind of modification that we have done to a normal sine x curve so that now it looks like this. And the domain in the graph is given for 0 to 2 pi. Now, A, B, and C are the positive constants. So, some important information that A, B, and C, all three values are positive. Now, we have to state the values of A, B, and C. So, based on this modification, I can first find the value of C. I know that my C is nothing but shift in y-axis. Basically, translation in y-axis. I know that my normal sine curve starts from 0 and over here it is starting from 3. So there is a positive shift in the y-axis of 3 units and therefore C will come out to be 3. Then let me talk about the value of A, which is nothing but the amplitude of this curve. So amplitude is nothing but the distance from that mean position and on the wave perpendicularly what is the maximum value, that is what we need to find. So obviously on this position with respect to the mean position, that is your amplitude. So if you count 1 2 3 4 boxes, so 3 to 4 5 6 7, so answer will be 4. Amplitude is coming out to be 4. And lastly we are having the value of B, which is also called as omega, which is nothing but 2 pi by the value of x, that is going to give us one complete cycle. So x cycle, this comes out to be 2 pi by pi, because for one complete cycle the value of x is pi, and then if you can see pi and pi gets cancelled out, I am left with 2. So what does this indicate? This indicates that my final curve is going to become y is equals to 4 sine 2x plus 3. So that becomes my final answer over here. Now let's move on to the second part. For these values of a, b, and c, we have to determine the number of solutions in the interval 0 to 2 pi for each of the following equations. So this a sine bx plus c and this a sine bx plus c is nothing but the same curve that is given to us in between 0 to 2 pi. Now on the right hand side, they are the straight line. This is already in the format of y is equal to mx plus c. If I just have to write it in bracket, it's going to become minus x plus 7. And over here, if I have to write this, it's going to become 2 pi x minus 2 pi. So you can see that it's in the format of y is equals to mx plus c. Over here also mx plus c. And therefore over here I can say that number of solutions will be equal to the points of intersections. Points of intersections. So because it's a straight line, I'll just need to figure out that in my minus x plus 7, what will be the value at 0 and the value at 2 pi. Based on that, I'll be getting the line, and that's it. The number of time it's going to cut this kind of curve, that will be equal to the number of solutions. So I know that my y will be equal to minus x plus 7. When the value of x is 0, obviously we can see that the y-intercept is 7. And similarly, if I'm going to put the value of x as 2 pi, so for that I'll need to open my calc. So minus 2 pi plus 7, if I'm doing, it comes out to be 0.7168. So somewhere over here you can say that. And now just try to draw a straight line. Obviously I'm not having a scale right now, so I'll just try to draw it freehand, but I hope you're going to get the idea. 1 2 3 4 and 5. Okay, just assume that this is a straight line, and yeah, because there are 5 points of intersections, I can state that there are 5 number of solutions. Similarly, for the curve 2 pi x minus 1, over here I'll just mention y is equal to 2 pi x minus 2 pi. So over here, if you just put the value of x as 0, answer will come out to be minus 2 pi, and minus 2 pi is going to be around minus 6 point something. So obviously it is way below this axis that is given to us. So let's see what is the value at 2 pi. So for that, again I'll need to turn on my calci, and for that 2 pi into 2 pi is my 2 pi square, 2 pi square, and then minus 2 pi. The answer comes out to be 33 point something. So again, it is way above this 8. It is way above. So I'll just try to substitute in the value of x as pi by 2. So if I do that, 2 pi into pi by 2, so 2 and 2 is going to be cancelled. It's going to be pi square. So pi square, oops, pi square minus 2 pi, it gives us 3.58. Okay, so somewhere over here is 3.5 over here, let's say. And let's check on pi, what happens on the pi. So 2 pi into pi, that is going to become 2 pi square, and then minus 2 pi. It comes out to be 13. So again, it goes way beyond this. And therefore now, if I just go ahead and sketch the curve with a different color, so it's coming from way below, right? And then it comes out to be something like this. It's a very steep line. It's not exactly a straight line, but I hope you're getting the point. Yeah, I'm not able to get it done. Okay, just assume it's a straight line. So we can see that there is only one point of intersection with the original curve, and therefore you are going to have only one point of solution. So that is how you solve your first question. Now for second question, it is from the arithmetic progression. The first term of an AP is minus 20. So A is given to us as minus 20. And then the common difference is 5. So the value of D is given to us as 5. Now we have to find the sum of the first 20 terms of the progression, which is very straightforward. So I know that the sum of the first 10 terms is given by n by 2 times 2a plus n minus 1 times t. Therefore, the value of S20 will be equal to n by 2. So the value of n is 20 in this case. So I can just say that 20 by 2 is 10. Then 2 into minus 20 is minus 40. Then I'm having 20, n is 20 minus 1, which is 19, times 5. And then if I just substitute everything in my calci, I'll be getting my value of the sum of the first 20 terms of this AP. And for that, I'll just do 10 into minus 40 plus 19 into 5, and then equal to, it gives me 550. So that will be my final answer for the first part of question 2. Now for the second part, it is given that the sum of the first 2k terms is 10 times the sum of the first k terms. So for this, I can write the equation. So for 2k, if I can show the formula, so in place of n, I'll just replace 2k, everything else is just the same. So 2k by 2 is simply k, right? 2k by 2 is k, then minus 40 plus 2k minus 1 into d, which is 5, is equal to 10 times. Now the value of n is k. So k by 2 into 10, so that becomes 5k, right? 10 by 2 is 5, and then you're also having the k. So 5k, and 2a is again negative 40. plus k minus 1 into d, which is 5. And this is what we got to solve now to find the value of k. So this k and this k gets cancelled out, and I can now open the brackets. Minus 40 plus 10k and minus 5. So my left hand side is done. On my right hand side, I am having 5 times minus 40 plus 5k minus 5, and therefore minus 40 minus 5 comes out to be minus 45 plus 10k is equals to 5 into minus 40 is minus 5 fours are 20, so 200, and then plus 25k, and lastly 5 into 5 is minus 25. And then if I just have to keep k on one side, so 25 minus 10 is simply 15, and now I'll just need to pull all the constants to the left side, and therefore if I pull out my calci, minus 45 plus 200 plus 25, sending all the constants on the left side because I brought my 10 to the right, and based on this I'm getting the output as 180. And therefore if I do 180 minus 15, sorry, 180 over 15, it gives me 12, and therefore the value of k that will come is 12. That's my final answer for part B of question 2. So for question number 3, we are given the equation of a curve that is in the quadratic format. Now there are 2 points A and B which lies on the curve such that the x coordinate for A is 2 and for B the x coordinate is 2 plus h. We now have to find and simplify the expression for the gradient of the chord AB in terms of h. So first of all, to answer this question, I would first draw the curve, the quadratic curve. This is how a quadratic curve looks like. We all know about that. Now let's say the x coordinate is 2 and the uh, x coordinate for B is 2 plus h. So if h is positive, my B point will be towards the right of A, or else if h is negative, then my B point will be towards the left of A. So let's go ahead and say that, for example, I'm going to mark my A point over here and my B point somewhere over here. That is h distance away from A. And my y, I don't know yet, so I cannot really find the change in y. But I can surely see that I'm able to get the chord between point A and point B. And this is a straight line. And because of that, I can easily find the gradient of this line if I'm having the coordinates of A and B. So the full point, x coordinate and the y coordinate for A and B, if I'm having that, I can find the gradient. So currently what I'm having is xa is equal to, so when xa is equal to 2, what is the y coordinate? How can I find the y coordinate? Well, if I plug in the value of 2 over here, I'll be getting the y value for this curve. So when my input will be 2, what is the output on the curve? It will be 2 into 2 square, which is 8. 8 minus 3 is 5. So I can say that my y comes out to be 5. So the coordinates of A is 2, 5. Similarly, when I put the input of x for the B coordinate as 2 plus h in the equation, what will I get for yb? So 2 is as it is, and then I need to square the x value. So in this case, I need to do 2 plus h square. So for that, the square of h is h square, then 2, that is on the square, then this 2 and this h, if I multiply them together, I'll be getting 4h. And then finally, the square of 2 is 4 minus 3. Now I can simply further simplify this. So it is going to become 2h squared plus 4 into 2 is 8h plus 8 minus 3, which is positive 5. So now this comes out to be my y coordinate for the point B. So my B is having 2 plus h as the x coordinate, and then 2h square plus 8h plus 5 as the y coordinate. Now because I'm having both the coordinates, I can simply go ahead and find the gradient of that chord AB, which is the change in y over the change in x. So change in y, if you see yb minus ya, it comes out to be 5 and 5 gets cancelled out. So 2h square plus 8h. And in the x direction, we can see that the difference is h, which you get by doing this minus this. So 2 gets cancelled out. We are left with h. Now this is not in the simplified format. I can still simplify it further. That is, I just need to take h as a common factor from the numerator part, and then it's going to become 2h plus 8. And in the denominator, I was having h. So this h and this h gets cancelled out. So finally, I'm left with my gradient of the chord AB that comes out in the format of h, or in terms of h, that is 2h plus 8. And that becomes the final answer for part A in question 3. Now for the next part, I explain how the gradient of the curve at point A can be deduced from the answer to part A, and then state the value of this gradient. So this is not the gradient of point A on the curve. This is the gradient of this chord AB, not this gradient. So how can we go from this chord to this tangent at point A? How we can go from this gradient of the chord to the gradient of this tangent at point A? Then if you are able to recollect the concept, this is coming from the questions of limits that we are having in the calculus. So in limits, we have studied that the moment this B comes closer and closer to point A, what's going to happen? Let's say, for example, from H it came to over here, maybe H by 2. Now this is the chord. There is some kind of a distance in X and Y as well. And now it comes more close to point A. Now this chord is going to be the gradient for that particular AB. And now if my B is very close to A, such that H becomes negligible, very close to 0, in that case, the gradient of that chord will be approximately equal to the tangent that I'm drawing over here. And therefore, what we need to say over here from the principles of limit, the first principle, we know that as B comes closer to A, such that the value of H approaches 0. In that case, the gradient of chord AB will be equal to the gradient at point A on the curve. So for this, I need to state that gradient at point A is equal to when the gradient of AB, if H approaches 0, my MAB will come out to be 2 into 0 plus 8 is 8. And therefore, the value of the gradient at point A, that gradient comes to be 8. So that becomes the final answer for your second part in question 3. Now in question 4, it is given that find the term that is independent of x, which is nothing but a constant term, because in constant like 3, 4, you don't have any term like x dependent on x. So you're looking for a constant term in the expansion of the following parts A and B. And if you notice in part B, there is the part of A that is attached to it. So if your answer to part A is incorrect, then obviously the answer to part B will also be incorrect. So let's pay proper attention and get our answers. So to find a constant term over here, you should be aware about the formula NCR, then the first term to the power of R, and the second term to the power of n minus R. And then if you compare the powers, you will be just requiring the power of x to be equal to 0, because we know that x power of 0 is equal to 1, which is a constant, and then there is no term with respect to x over here. So if I try to make this kind of an equation for us over here, it will be 6CR into x to the power of R into 3 times x power of minus 2 to the power of 6 minus R. And now I want to say that how can I make the power of x equal to 0? So I just need to compare the powers of x now. Compare powers of x. Powers of x on both the sides. So while doing this, on the left side I'm having x power of r, which is just the r, then minus 2 into 6 minus r. So minus 2 into minus r will become plus 2r, and then minus 2 into 6 is minus 12, and then I want this is equal to 0. So for what value of r? This will be equal to 0. So if you just go ahead and try to solve this, it will be 3r is equal to 12. So 12 by 3 is 4, so r will come out to be 4. So when my r is equal to 4, I'll be having a term that will be independent of x. I can show it to you over here. 63, sorry, not 3 but 4. 64 into x power of 4 into 3x power of minus 2 to the power of 6 minus 4 is 2. And now if you expand this, let me take off my calci. 64, what is the value of 64? After that, there is no constant that is multiplied with x, so I don't need to write anything in the calci. But for 3, it is 3 square, which is 9. So 64 into 9, if I get, it is going to be 135. So 135 is what I'm having. And then if you look into x, it is x power of 4 into x power of negative 4. So it is x power of 4 into x power of negative 4, which comes out to be 1. It is same as writing x power of 4 by x power of 4, which is 1. So that is exactly what we have got. And therefore, the final answer for part A of question 4 comes out to be 135. Now, let's move on to the second part. Again, we need to find the term that is independent of x in this expansion. So if you notice carefully, my 4x cube needs to be multiplied with something over here so that x cube get cancelled out. And it is only possible if we know over here term in x cube with a negative sign in the power. So that this x cube and this x power of minus 3 gets cancelled out. And I'm left with only the constant. And then for the minus 5, because this term is already independent of x, what can I multiply in this expansion so that I get a constant? That is 135 itself. And therefore, what I need to do is I first need to find out what is the value of r if I want to get the power of x to the minus 3 for this bracket. So in that case, I can use the equation that I got over here. On the left hand side, there is no changes at all. On the right hand side, now the power is equal to negative 3. So for what value of r, I'll be getting x power of negative 3. So it will be 3r minus 12. I got 3r minus 12 from this side is equal to negative 3 because that is what I'm looking for. And then this is going to give me the value of r as 12 minus 3 is 9. 9 by 3 is 3. So r comes out to be 3. And now because of this, I can state that term in x minus 3 is 63 x power of 3 and 3x power of minus 2 to the power of 6 minus 3, which is 3. And now I again need to take out my calci and get this done. 63 into 3 cube is 27. So I got 540. So 540 into x cube into x power of minus 6. So that is going to be minus 6 plus 3 is minus 3. So that's going to give me x power of negative 3. And now finally I can go ahead and state that 4x cube multiplied by 540x power of negative 3 will give me a term that is independent of x. And similarly, this minus 5, if I multiply with 135 that I got from the expansion of this for the constant term, this will be the two terms we'll be getting that are independent of x, which I then need to add them algebraically. So what is 4 into 540? Let's check. 4 into 540 is 2160. And then what is minus 5 into 135? It is minus 675. So the only one thing that I'm left to do is I just need to add them. Therefore, term independent of x is 2160 minus 675. 2160 minus 675. That is 1485. That is your final answer. So that's how you solve the question on the binomial expansion when the power, you are aware about what kind of power you require, but then you want to find out the value of r. It is straightforward. If this is something that you were never aware about, just make sure you are aware about this concept and you can solve any kind of questions in binomial expansion. So for question 5, the function f is defined by this for x less than half. And now we have to state the value of f of minus 1. So I just need to substitute the value of x as minus 1. So for the top part, I'll be getting minus 2 plus 1, which is minus 1, divided by minus 2 minus 1 is minus 3. So if I just simplify it further, I'll be getting 1 by 3. Then for the second part, the diagram shows the graph of y is equal to f of x. Sketch the graph of inverse function on this diagram. Show any relevant mirror line. So to sketch an inverse function of any function, we know that it's a reflection of y is equal to x line. So I'll just first draw the y is equal to x line. Okay, I'm not having a ruler right now, so it's going to be a bit slow, but please go ahead and use rulers, and that is how it is going to look like. And now we know that in the inverse function, my y becomes x and my x becomes y. So if x comma y is a coordinate of a normal function, the reflected value will be y comma x for the inverse function. So let's say if I want to mark this point on this for the inverse function, the x value is minus 4 and the y value is somewhere around 0.9, let's say. Okay, minus 4 comma 0.9. That was for f. So for the f inverse, it's going to be reverse. 0.9 in the x-axis, so over here, and minus 4 in the y-axis over here. Okay, now let's talk about this point. So this point was at 0 comma minus 1. 0 comma minus 1 was at f. So for f inverse, it will be minus 1 comma 0. So minus 1 comma 0 is over here. So the reflection of this point is over here. And obviously, this is also going to intersect at this point because it's a reflection. So on the mirror, it's going to intersect. Then similarly, if I want to check the coordinates of this point in my inverse domain, so currently it is, let's say, 0.3 comma negative 4. That is for your normal f. So it is going to be minus 4 comma 0.3 for your inverse function. So minus 4 comma 0.3 somewhere over here. And now I just need to connect these dots that I've drawn. I'll just maybe use some different color and show you that it's going to be like this. Oops, I'll require a flat surface. Just a second. Yeah, I'm trying to draw it as good as possible, but I hope that you're getting the point. So that's the graph that we have got for the y is equals to f inverse x. Now for the third part, find the expression of the inverse and state the domain of f inverse. So I know that the domain of f inverse is simply the range of f of x. And now if I just look into the curve for this black line, I can see that it is always staying under this line y is equal to 1. So the maximum value for the function is 1. It can never cross the 1 and 1 is exclusive. And for the minimum value, I can say that it is going to the lower infinity. negative infinity. So I can state that range of f inverse, or I can just say that this is equal to fx less than 1, because f of x was less than 1. Now x will be less than 1. So domain of f inverse x is x less than 1. Now let's find the expression for f inverse x. So for f of x was 2x plus 1 over 2x minus 1. 2x plus 1 over 2x minus 1. I now just need to make x my y and y my x. Therefore, this is going to become x is equal to 2y plus 1 divided by 2y minus 1. And then if I just do the multiplication on the other side, it's going to become 2 into xy minus x is equal to 2y plus 1. I'll take all the y terms on the left hand side, and therefore this will become 2xy minus 2y is equal to x plus 1. And now if I take y as common factor, then this will implement that y 2x minus 2 is equal to x plus 1. And yes, I got my y is equal to x plus 1 divided by 2x minus 2. And therefore I can mention that my inverse function is equal to x plus 1 over 2x minus 2 for x less than 1. And then guess what? This becomes my final answer. Now, the function g is defined by g is equal to 3x plus 2. And now we are asked to solve f of x is equal to g of f of 1 by 4. So we know that f of x is equal to 2x plus 1 over 2x minus 1. I'll just compare it. 2x plus 1 over 2x minus 1, yes. Now, this is going to be equal to g of f of 1 by 4. So first of all, what is the value of f of 1 by 4? For this, I'll need to have my calci. So I'll say that 2 times 1 by 4 plus 1 divided by 2 times 1 by 4 minus 1. And my answer comes out to be minus 3. So f of 1 by 4 is minus 3. Now I need to pass this as an input to g, and therefore g of minus 3 will be equal to 3 times minus 3 is minus 9, minus 9 plus 2 is minus 7. So on the right hand side, we are having the value of minus 7. On the left hand side, we are having this equation, and then we just need to find out the value of x. So 2x plus 1 by 2x minus 1 is your f of x. On the right hand side, you are having minus 7. And now if I just solve it, 2x plus 1 is equal to minus 14x plus 7. I'll keep x on the left side, so it becomes 16x. On the right side, it is becoming 7 minus 1, which is 6. And therefore, your x will be equal to 6 over 16. That is equal to 2 times 3 is 6. 2 times 8 is 16. So 3 over 8 becomes your final answer. So now in question 6, the diagram shows a metal plate OABCDEF, that is OABCDEF, okay, consisting of sectors of two circles. So we can see that there are two sectors for two different circles, each with the center at O. The radii for sectors AOB and EOF. So AOB and EOF is R, as we can see. So even this is R. I'll just mark it for the sake of marking the diagram. And the radius of the sector COD. So COD is 2R. So if this is R, And if they mentioned this 2r, it is just a bit confusing. I'll just mention this as r as well, and this is r as well. So this r plus r makes it 2r. Now the angle of AOB is theta. It's same as angle EOF, and the radians, it's given in the radians obviously, and angle COD is 2 theta radians. It is given that the perimeter of the plate is 14 centimeters and the area of the plate is 10 centimeters. And for this values of r and theta, like within this range, we need to find the values of r and theta. So first of all, if I have to mark the perimeter, let me choose a red color for that. So the perimeter will be, this is r, then this is the arc length that is given by r into theta. Then we are having this r, and then again if we have to find the arc length of this sector, it's going to become 2r into 2 theta, which is 4r theta. Then this is r, this is r theta, and this is r. So based on this, I can say that my perimeter, that is equal to 14 centimeters, equals to the summation of all these values that I've written over here. Obviously the middle part is not the metal plate, it is within the metal plate, so we are not going to count this thing in the middle. And therefore the equation that I'm going to write over here is, so r theta is coming twice over here and over here, so I'll write 2r theta. Then there are 2 r's over here, 2 r's over here, so 4r plus this 4r theta, and this is all equal to 14. And if I simplify it further, it is going to become 6r theta plus 4r is equal to 14. And the other equation that we get is from the area of the plate. So area of this thing will be half r square theta, and the same thing will be for this. So half r square theta into 2 will be r square theta plus it is half r square into theta. So that is going to become half 2r square is what, 4r square into 2 theta, and this is equal to 10. And therefore if you see that this 2 and this 2 gets cancelled out, so I'm left with 4r square theta plus r square theta, that is 5r square theta, which is equal to 10. And this implies that r square theta is equal to 2. Now we are having two equations, one for this and one for this. Now what I can do is, I can simply state that my theta over here will be equal to 2 over r square. I can now substitute this theta in this equation so that we get 6r into 2 by r square plus 4r is equal to 14. And if I solve it further, I can say that this r and this r goes, so I'm left with 6 times 2 is 12, 12 over r plus 4r is equal to 14. And now I can multiply r on both the sides, and I'll be getting 12 plus 4r square is equal to 14r. So now this becomes, as you can see, it's a quadratic, so I'll write 4r square minus 14r and plus 12 is equal to 0. And now what I can do is, I can take out my calci and say that mod 5 3, 4 minus 14 and 12. This gives me the one of the answers of r is 2 and the other is 3 by 2. And clearly we can see that r must be greater than 3 by 2. So 3 by 2 solution will be rejected. The way that I will be writing my answer over here would be r minus 2 and 2r minus 3 is equal to 0. Then this will say that r is equal to 2 or r is equals to 3 by 2. Now clearly I can just go ahead and say that I can reject this and accept the value of r as 2. And now that I've accepted the value of r as 2, what can I do further? I can simply go ahead and put the value of r over here as 2, and this is going to implement that theta is equals to 2 over 2 square, which is equal to 0.5. And that is going to be the final answer for your question 6. Now in question 7, in the first part, we are asked to express this quadratic equation in its completing square format, where this a, b and c values are positive integers, and then find the coordinates of the vertex. So the x and y coordinates for the vertex of this graph. So usually it is not compulsory to express this equation into its completing square and then we get the vertex. We can also do it without this formula. But now that we are asked to do this, you should know that if we are in the completing square format, then the vertex is given by the negative of the value written over here, that is b in this case, and then c as it is. So b comma c will give us the final value. So first we need to find out the values of a, b, c, and then b comma c will be the coordinates of the vertex of this graph. So in that case, first of all, what I'll do is I'll write that y is equal to, I'll take minus 2 as the common factor from the first two terms and keep 11 out of this. So it's going to become minus 2 times x square plus, or I should write minus 4x, and then 11 outside of this bracket, so that we get minus 2x square, then plus 8x. So yeah, this equation is holding true. Now I'll apply the computing square for this term in the bracket. So it's going to become x minus half of this is 2. So it becomes x minus 2 the whole square. Now if I open this bracket, I must get this term. This is what I'm looking forward to. So if I open this bracket, I'll be getting my x square term. If I square this, then if I multiply these three things, I'll be getting minus 4x. And then if I square the minus 2 term, it is going to give me plus 4. But plus 4 is missing over here. It's not there. So to get rid of that plus 4, I'll need to have this minus 4, so that if I'm going to get x square minus 4x plus 4, this minus 4 will cancel that out. And then the plus 11 is outside of this bracket, so no worries. Now I simply need to multiply my minus 2 inside this bracket, so it's going to become minus 2 into x minus 2 square. And then this is positive 8 plus 9, plus 11 is 19. So based on this, I can say that therefore vertex is given at 2 comma 19. So that becomes your first answer for question 7. Now for the next question, the diagram shows the part of the curve. So we are given, first of all, this is the quadratic equation and that is what is curved, and the other equation is given for the equation of the line. So this is your equation of the line that I have marked on the graph. Now we have to find the area of the shaded region. So to do this, it's a very classic question that we have for the integration. I first of all need to find out what are the points of intersection so that I can know between what x values or which x values I'll need to integrate this. And then once I'm aware about this bounds, I'll first integrate my curve to get the area under the curve, and then I'll subtract it from the area of the trapezium or the area under the line between these bounds, so that this extra white part from the area under the curve is gone and I'm just left with the area in between the curve and the line. So idea is pretty simple, straightforward question. I'll first need to find the points of intersection. So in order to do this, I'll need to equate both this equation, that is minus 2x squared plus 8x plus 11 is equal to 8x plus 9. And I can see that 8x and 8x goes out. I'm left with minus 2x squared is equal to 9 minus 11 is minus 2. And therefore, I can clearly see that my either x will be equal to 1 or minus 1 and the other value will be equal to 1. Because this minus 2 and minus 2 gets out, so I'm left with only 1. So if my x square is equal to 1, I know that my x will also be equal to plus or minus 1. So this becomes my minus 1, this becomes my 1. And now I just need to go ahead and get the integration part done. So if you can see that for both of these equations, for the quadratic and even for the straight line, the bounds are same. So I can simply go ahead and say that the integration of this minus this from minus 1 to 1 will give me the area of the shaded region. And for that, I'll do this integration of from -1 to 1 of -2x squared plus 8x plus 11 minus 8x minus 9 dot dx. I can further simplify this. So it's going to become integration from -1 to 1. So minus 2x squared, then 8x and 8x goes out. I'm left with 11 minus 9, which is plus 2 dx. And therefore, if I solve this further, so the integration of minus 2x squared will become minus 2x cube over 3. So minus 2x cube over 3. And then for this 2, it's going to become plus 2x. So the bounds are -1 to 1. And if okay, thankfully we're having the space and we can continue further over here. So the shaded area is equal to, I'll just need to substitute the value of 1 inside this. So it's going to become -2 by 3 plus 2. So -2 by 3 plus 2. And then a negative sign in between. -1, if I put over here, it's going to become positive 2 by 3 and minus 2. So it is 2 by 3 minus 2. So I'm going to get -2 by 3 and -2 by 3 as -4 over 3. And then this is going to become plus 2, which is 4. So 4 times 3 is 12. 12 minus 4 is 8. So the answer comes out to be 8 by 3 unit square. So this is the final answer that I'm getting for the shaded region or the area of the shaded region. Now for question 8, the equation of a circle in this format is given to us where P and Q are constants. Now in the first part, we have to express that equation of a circle in this format where we know that A comma B is going to be the center of the circle and R will be the radius of that circle. And we have to express that equation in this format where A is going to be expressed in terms of P and R square in terms of P and Q. So the first thing that we are going to do over here is we're going to collect the like terms together of this equation. So x terms I'll be taking together inside a bracket. It's going to become x square plus px. And there is no other term in x. So I'll go for the y term. So I'm having two terms, y square plus 2y. And one term that is independent of x and y is q. So I'll keep it on the right hand side. So it becomes minus q. Now, if you can notice, on the x we are having a square, on the y term we are having the square. So what comes to your brain? Yes, computing square is the correct answer. So over here, if I do the computing square for the x term, it's going to become x plus the half of p, that is going to be p by 2. And if I square this, I hope that when I open this, I get this term. So x square plus 2 into x into half p is going to give me px plus p by 2 the whole square is p square by 4. So now because p square by 4 is missing in this particular term of x, I need to get rid of p square by 4, and that is why I am just deleting p square by 4 in this expansion of x term. And the same thing needs to be repeated for y. So if I take the computing square of this, it's going to become y plus the half of 2 is 1. And if I square it, I'll get an extra term that is of plus 1 because y square is given, 2y is also there, but plus 1 square is missing. So I'll do -1 so that 1 and 1 gets cancelled out and we get exactly this. And this is all equal to negative q. And therefore now if I just rearrange this, it's going to become x plus p by 2 the whole square plus y plus 1 the whole square is equal to all the constants on right hand side. So it's going to become p square by 4 plus 1 minus q. And what do we notice over here? Straight away I can see that in place of a I need to have minus a, but no worries, I can simply state that a is equals to negative p by 2 and my r square is equal to p square over 4 plus 1 minus q. And guess what? This is the final answer that we are having for part A of question 8. Now, obviously, there are some of the shortcuts that are always there, okay, to get this answer directly. But I don't want you to remember a lot of shortcuts. This kind of things can be derived very quickly. So I'm always a big believer that if you are able to derive it very quickly, because see, it took me a lot of time because I was explaining you each and every steps. But if you have to do this kind of steps in the examination, it's going to take less than 30 seconds to get this done. Okay. So don't try to remember a lot of formulas. Rather focus on how you can remember less and less amount of formulas and derive more of the things right over there in the paper in less amount of time. So if you focus on that, you will have to remember very less things in terms of equations and the formulas and everything, and things will come out naturally from your brain and you will be getting most of the marks from the paper. Now, given that, let's move on towards part B. Now it is given that the line with the equation is tangent to the circle at point A. So it's the same circle we are talking about. So let me just draw a quick circle over here, and then the center point is what? Minus p by 2 and minus 1. So minus p by 2 comma minus 1 is the center. And let's say there is a point A somewhere over here whose tangent, if I'm drawing, obviously I'm not keeping in mind what is the orientation of the gradient, if the line should be like this or should be like this. I am not taking that into consideration. This is just to help me get started with, like, what exactly I'm supposed to do over here. We are asked to find the equation of the normal of the circle at point A. So basically, we are asked to find this equation, that is normal or perpendicular to this tangent at point A for this circle. So for this, the first thing I'll need to find is what is the gradient of this line, because the coordinates of A are given to me as 4, 3. And even the equation of line is given to me as x plus 2y is equal to 10. So if I find the gradient of this line, finding the gradient of this line is nothing but the negative reciprocal of this. And once I'm having the gradient and a point that is existing on this line, I can find my y-intercept as well. So I'll tell you how we are supposed to do this. So first of all, we are going to write x plus 2y is equal to 10 in the format of y is equal to mx plus c. So it is going to become 2y is equals to minus x plus 10, and then if you divide 2 on both the sides, you're going to get y is equals to minus half x plus 5. So from here, if gradient was minus half for the gradient, sorry, what am I saying? If the minus half was the gradient for the tangent line for the point A, then the negative reciprocal will be the gradient for the normal line at point A. So negative reciprocal of minus half is what? So this is basically implementing that gradient of normal is equals to negative 1 of negative half, which comes out to be 2. And thus I'm going to write my equation of normal is going to become y is equal to 2x plus c, where 2 is the gradient obviously, and we just need to find out the value of c by substituting the value of x as 4, y as 3, and that is where it's going to become 3 is equals to 2 times 4 is 8 plus c. From here we can clearly make out the value of c is coming out to be minus 5. So c is coming out to be minus 5. So what is the equation of the normal that we're getting over here? So we can mention that equation of normal is equal to, or not equal to, but this dots y is equal to 2x minus 5. And this becomes the final answer for the first part of B. Now moving down, we are having the second part where we are asked to find out the values of P and Q. So to find out the values of P and Q, the first thing that comes to my mind is if I am able to find out the value of P, then I can find my value of Q as well. How? So first of all, I am already aware about the gradient of this line. So by utilizing the coordinates minus p by 2 comma minus 1 and 4 by 3, I can find out the equation of gradient in terms of p. And because this is equal to 2, I can get the value of p right over there. Then once I'm getting the value of P, I can also find the value of the radius of this circle by using the distance between the 2 points formula. And then once I'm having the radius, I can square that and equate it to this term. And now that I'm also having the value of P, I can find out the value of Q. So based on this, let me show you how we can solve part 2 of question B. So I'm going to state that M of normal is equals to the change in y. It is going to become 3 minus minus 1, which is 4, divided by change in x. 4 minus minus p by 2 is 4 plus p by 2. And I also know that this is equal to 2. So I can say that 2 is equals to 4 by 4 plus p by 2. And now if I just solve it further, it's going to be something like 2 times 4 is 8, then 2 times p by 2 is p is equal to 4. So from here we are getting the value of p that is coming out to be minus 4. So that is the answer that we are having for the value of p as asked in the question. Now because we are having the value of p, I can state that this coordinate is minus of minus 4, which is positive 4. 4 by 2 is 2. So this is going to become 2 comma negative 1. So now using this 2 coordinates, I can also find the radius. So I can say that the next step on top of this is my r square is equal to uh, the distance between these two things will be 4 minus 2 square, 4 minus 2 square plus 3 minus minus 1, which is 4. 3 minus minus 1 square. So if I just solve this, I'll be getting 4 minus 2, that is 2. 2 square is 4. And then this is 4. So this is going to become 16. So 16 plus 4 is equal to 20. So r square is coming out to be 20. And therefore, what I'm going to do is, I also know that r square is equal to p square by 4 plus 1 minus q. So p square by 4 plus 1 minus q. The only unknown now I am having is the value of q. So r square is 20. My p value was minus 4. So minus 4 square was 16. 16 by 4 is 4. So 4 plus 1 minus q is what I'm having. So I'm going to get, I'll keep my q on the left side and shift my 20 on the right side. So 5 minus 20 is minus 15. So the value of q that we are getting over here comes out to be minus 15. And then this is the value of q. The value of p we have already found, and that's how you solve the part 2 of part B in question 8. Now for question 9, it is given that the equation of a curve which is in a quadratic form, and then the equation of a line that is given to us like this, where k and p are constants. So this k and this p are constants. And there is a restriction given for a constant k that it must be within 0 and 1. And there is no such restriction for constant p. And in part A, it is given that one of the point of intersection of this curve and this line has coordinates 5 by 2 and 1 by 2. So whenever in both this equation the value of x will be 5 by 2, the output will also be 1 by 2. That is one fact that we are aware about. Now based on this, we can find out the values of k and p. And then once we are having the values of the k and p, we can also find the coordinate of the other point of intersection, because we know that in the quadratic curve, if there is a line, at max we can get two solutions, or the other possibility is we can get only one solution, or the other possibilities we cannot get any solution. So in this case, they are telling us that there are 2 points of intersection. One point is already given to us, and the other point we need to find based on the values of k and p. So what is the first thing we can do? And it is of 7 marks, by the way. So well, if you focus on this equation of the curve, it is completely in form of k. There is no p involved over here. So what I can do is, because I know that 5 by 2 and 1 by 2 is valid for this equation, I'll substitute my x as 5 by 2 and y as half. Then what's going to happen is this whole equation will be completely in format of k only. There is no p, no x, no y. And then because the equation is just in terms of k, I can go ahead and get the value of k that is in between 0 to 1. Then once I'm having the value of k, I can use that k. I can again use the value of x as 5 by 2 and y as 1 by 2 to get the value of p, because even this point is satisfied for this equation. And therefore, I can go ahead and state that substitute 5 by 2 comma 1 by 2 in equation of curve. Equation of curve. And now I'm going to change the color of my pen, and it's going to be half is equal to half into 5 by 2 square. So what is 5 by 2 square? It is 25 by 4. So 25 by 4 into half is 25 by 8. So it is 25 by 8k square. Then minus 2 into 5 by 2 is 5. So minus 5k plus 2. And now I can see that 8 is in the denominator. I can multiply 8 on both the sides so that I'm rid of any kind of denominators. So 8 into half is going to be 4. 25 by 8 into 8 is 25. Then 5 into 8 is 40. 8 into 2 is 16. And I'll keep everything on one side. So 25k square minus 40k. Then plus 16 minus 4 is plus 12 is equal to 0. Now I'll just bring out my calc and try to solve this in my calc itself. So 25 minus 40 plus 12, it gives me the values of k as 6 by 5, which is obviously greater than 1. So 6 by 5 will be rejected because it's not falling under this constraint. And then the other value is 2 by 5. So because this is in between 0 to 1, then 2 by 5 becomes the solution for k. So I can go ahead and say that I got the values of k as 6 by 5 or k is equals to 2 by 5. And based on this, I can make the factors 5k minus 6 is 0. Oh, sorry, oops. Or 5k minus 2 is 0. So these are the factors I got just by looking at the roots from the calc. And based on this, I can say that reject this and we are going to accept this. Now because we are accepting this, I can substitute this value of k, this value of x, this value of y in this equation to solve for p. And I can say that now substitute k is equals to 2 by 5, x is equals to 5 by 2, y is equals to half in equation of line. And that is going to give us p. Again, I'll go back to my purple color. So it's going to become y is equals to, so half is equals to, k was 2 by 5, x is 5 by 2, and then we are having plus p. So this is half is equals to 1 plus p. Therefore, the value of p comes out to be minus half. And that is how you solve the first part of this question, where we are just getting the values of k and p. Now once we are having the value of k and p, we are also asked to find the coordinates of the point of intersection, the other point of intersection. So now for that, what I can do is, because I need to find the point of intersection, first I'll need to equate my equation of curve with equation of line, and by using the values of the k and p that we just found out. And then I'll just have my equation in format of x, which I can go ahead and solve it. And I'll be getting one of the x value as 5 by 2, which I don't need to consider because I've already found that kind of thing in my question. And the second value of x is what I'll be forwarding with to get my value, the respective value of the y. So it's going to look something like this. So I'll mention that based on this, based on this, equate equation of line and curve. And it's going to be something like this. half into k square. So half into 4 by 5. Half into 4 by 5 will become 2 by 5. So 2 by 5 x square. Then we have minus 2 into 2 by 5, which is minus 4 by 5 x. Then we have plus 2 is equal to 2 by 5x, 2 by 5x, and minus half. So I'll just bring everything onto the left hand side, so that it's going to become 2 by 5x squared minus 4 by 5x. Oh, there is also minus 2 by 5x. So 4 by 5 minus 2 by 5. So 4 and 2 with a negative sign will become 6 by 5x. And then we are also having 2 plus half. So 2 plus half will become 5 by 2. And this is equal to 0. And now I'll just be using the quadratic formula stating that a is equals to 2 by 5, b is equals to minus 6 by 5, my c is equals to 5 by 2, and using x is equal to minus b plus minus square root of b square minus 4ac, and this is whole divided by 2a. I'll be getting two values of x, where one will be for sure 5 by 2, and the other value we'll just need to find. So I can again use my CAIE and plug in these values directly. A value is 2 by 5, b value is minus 6 by 5, and then the c value is 5 by 2. So the first, okay, I guess I did some mistake over here. 2 by 5, then minus 6 by 5, and then 5 by 2. Okay, so there is some kind of a mistake that we have done. Let me just quickly cross check it. So 2 by 5 x square we got from this. So half into 4 by 25. Oh, okay, not 4 by 5. So it's going to become 2 by 25. Okay, that was the only mistake I guess I can spot. So 2 by 25 is what I'll need to write. And based on this, I can go ahead and again, so 2 by 25 and equal to, so yes, now I'm getting the value of x as 25 by 2 and 5 by 2. So x is equals to 25 by 2 is one of the answer, and the 5 by 2 is already something that I told you we'll be getting. So I can mention that this is something that we already have. We have this already, and therefore we are going to carry forward with x is equals to 25 by 2. And now what I'm going to do is, to find the y value, I'm going to use my x is equal to 25 by 2 in this equation to get the value of y. So substitute x is equals to 25 by 2, k is equals to 2 by 5, and p is equals to minus half in equation of line. And that is going to give us the value of y, that is the other point of intersection. So y is equals to kx plus p, kx plus p, and therefore my y will come out to be 2 and 2 goes 5, 5 minus half is 9 by 2. So 9 by 2 will be your y coordinate for the intersection. And I can simply mention now other point of intersection is coming out to be 25 by 2 comma 9 by 2, and that is how you get the final answers for your first part. You got the value of p, k, and also the other point of intersection. Now moving on towards the part B, they are saying that it is given instead that the line and the curve do not intersect. Now because the line and the curve do not intersect, the b square minus 4ac condition will be less than 0. And from this we have to find the possible values of p. Okay, somehow they are not asking the values of k, only the values of p. So let's see how is it going to look like. So now I need to equate these equations directly. So half kx square minus 2kx plus 2, half k square x square minus 2kx plus 2 is equals to kx plus p. I'll just cross check if everything is correct. So kx plus p is correct. Half k square x square minus 2kx plus 2 is also correct. Okay. Now I'll shift everything to one side, so it becomes half k square x square minus 2k minus kx will become minus 3kx, then plus 2 minus p is equal to 0. And then I'll just write a condition as line and curve do not intersect, then b square minus 4ac will be less than 0 of this equation. So after this I'll just say that therefore b square minus 3k square will become 9k square minus 4 ac. So a is half into 4 is 2, so 2k square, and c is 2 minus p, and this is less than 0. Now I can just take k square in the common, so k square is common, so I'll be getting 9 minus 2 times 2 minus p, which will become minus 4 plus 2p less than 0. So from here we get k square is either less than 0 or 9 minus 4 plus 2p is less than 0. From here we won't get any kind of solution because we know that k lies in between 0 to 1, so we can go ahead and reject this condition. And obviously we did not really want to solve for k, we had to solve only for p. So continuing this forward, 9 minus 5 is 4, 9 minus 4 is 5 plus 2p is less than 0, and therefore p will be less than minus 5 by 2. And that is the final output that you're getting for the set of values of p for which the curve and the line will never intersect. Now for question 10, a function f with a domain such that x is always greater than 0 is such that the derivative of that function is given to us as this, and it is also given that the curve with this equation passes through the point 1 comma 0. And we are asked to first of all find the equation of the normal to the curve at point 1 comma 0. So what does this mean? Let's say for example I am having a curve like this, and at this point you are having a coordinate 1 comma 0. Now if you pass a tangent at that point, something like this, it's not exact, but just imagine it's a tangent passing through that point. Okay, so if I substitute the value of 1 into this equation, I'll be getting gradient of this line. So f dash 1 will be the gradient of this line. But in this first part, if you notice, we are asked to find the equation of the normal. So what is the normal of this curve at point 1 comma 0? That normal line is the green line that I'll be drawing over here. So this is the line that we are asked to find. So to get this gradient, this will be equal to minus 1 by f dash of 1. So let's go ahead and find, first of all, what is f dash 1? So it is 8 times 2 into 1 is 2, 2 minus 3 is negative 1, negative 1 to the power of 1 by 3 is what? Negative 1. Then we are having minus 10 times 1 to the power of 2 by 3, which is 1 only. So this comes out to be minus 8 minus 10, which is minus 18. And therefore, the gradient of the normal will come out to be minus 1 by minus 1, 18. So minus 1 by minus 18 is 1 by 18. So I can say that the equation of normal is y is equals to 1 by 18x plus c. Now if we keep the value of y as 0 and the value of x as 1, this means that c comes out to be minus 1 by 18. And therefore, equation of normal becomes y is equals to 1 by 18x minus 1 by 18. So that is your final answer for the first part. Now for the second part, we are asked to find from this derivative function, we have to find the actual equation of the curve. So that is y is equals to integration of f dash x. So if we integrate this, only then we are going to get the equation of the curve. So y in this case is nothing but f of x. So I will say that my f of x is equal to integration of f dash x dx. That is equal to integration of this term. So to integrate this, I'll first integrate this part and then this part. So to integrate the first part, 8 is going to come out as a common. Then I'm having the integration of 2x minus 3 to the power of 1 by 3. 2x minus 3 to the power of 1 by 3 dx. And then minus, over here I'll take 10 as a common. And then integration of x to the power of 2 by 3 dx. Now, I'll keep 8 as it is and then multiply this with the integration of this part. So I'll keep 2x minus 3 as it is. And then I'll increase the power by 1. So 1 by 3 plus 1 will become 4 by 3. So this is 4 by 3 divided by 4 by 3. But now this 3 can come on the top. So I'll write it as 4 into 3. And then we're also going to divide this with the derivative of the inside function because of the reverse chain rule. So that derivative comes out to be 2 minus 10 into x to the power of what is 2 by 3 plus 1. It is 3 plus 2, 5 by 3. So 5 by 3 over 5 by 3, but the 3 goes on the top. And then the common constant of integration will be c. So this comes out to be 4 times 2 is 8. So I can cut this 8 with this 8. So I'm left with 3 times 2x minus 3 to the power of 4 by 3 minus 5 times 5 times 2 is 10. So 2 times 3 is 6. 6 times x to the power of 5 by 3 plus c. So that is your function. This is the function. But now in terms of c, to find out the value of c, I'll need to substitute my x as 1, y as 0. So my function output will be 0 when my x value is 1. So 2 times 1 is 1, 1 minus 3. 1 minus 3. I hope I have not done any mistake on the top. It was okay, 2. Okay, I got it. So 2 into 1 is 2. 2 minus 3 is minus 1. Okay, now it makes sense. So minus 1 to the power of 4 by 3. What does it come out to be? So it's going to become minus 1 to the power of 4 will become positive 1. So positive 1 to the power of 1 by 3 will become 1 only. So it's going to become 3 times 1 minus 6 times 1 plus c. So this implements the value of c will come out to be 3 minus 6 is minus 3. So c will come out to be 3. And therefore your function is equal to 3 times 2x minus 3 to the power of 4 by 3 minus 6 times x to the power of 5 by 3 plus 3. And that is your final answer to part B. Now, it is given that the equation f dash x is equal to 0 can be expressed in this format. Determine, making your reasoning clear, whether f is an increasing, decreasing, or neither of these functions. So to get this thing done, what I can do is I can just first of all look into what this f dash x was given to us. Okay, so we can convert this equation into this format, and By using this equation, we have to state that if it's an increasing function, decreasing function, or neither. And for this, the one idea that comes to my mind is we can convert this into a completing square format. And from the completing square format, there will be a square, and then there will be some kind of either plus or minus a value. And from this, we can conclude that if this is a positive and if this is positive or negative, how the output is going to look like, such that the value of x is always greater than 0. And for that, I'll just get rid of everything else and try to convert this into the completing square format. So I can say that my f dash x is equal to, I'll take 125 as a common factor, and then x squared minus 128 over 125x. I'll keep 192 outside of this, and then this is going to become 125. Then x, I'll just have a small parenthesis, x minus 128 by 2, which is going to be 64 by 125 square. And then once I open this bracket, I'll have these first two terms, but I'll also have the another term that is the square of 64 by 125. So I'll need to get rid of 64 by 125 square and then plus 192. And now I'll simply need to multiply my 125 with this, that is x minus 64 over 125 square minus 64 square. I'll take out my calci now. So minus 64 over 125. So square of this into 125. What is the answer? It comes out to be this, but then I'm also having plus 192. So I'll do answer plus 192, and that comes out to be 19904 by 125. 19904 by 125. So now, because this is equal to your f of f dash x, we know that for a function to be increasing or decreasing, f dash x will be greater than 0 for increasing, it will be less than 0 for decreasing, and if your function is a constant, your f dash x will come out to be 0. So in this case, I know that whatever is the value of x, if it's greater than 0, because of the square term, this term will always be positive. So because this term is positive, it is getting multiplied with a positive value. This whole term is greater than 0. And in a greater than 0 term, if I'm adding a positive value, it is always going to be positive. So if my f dash x is always greater than 0, this implements that my function is an increasing function for x greater than 0 domain, or for any values of x for that matter. But then this will become your final answer. F is your increasing function. Alright guys, then that's it for this paper over here. If this was helpful to you, please make sure to drop a like and share it with your friends ahead, and don't forget to subscribe for more such videos in the future.